So this is our final year project titled Cloud-Based OTA Firmware Update. We are the master student at San Jose State University. So the term OTA stands for over there. So this video is meant to demonstrate you the working of our project. So before jumping into demonstration, let me give you a brief background of what we are trying to do over here. Okay, so let's imagine, right? So you have a product, okay, and your product will certainly use some of the embedded controller, right? And let's say that embedded controller is running a firmware. Now like your product is being used by some customer, okay? Now in future you decided to add new features to your product, or let's say you fix some bugs, okay? Now how will you make this new updates reflect onto product which are already there or already shipped out? One way to do that would be ask the customer to ship you back the product, and then you perform the firmware updates using a JTAG or a USB or whatever, right? And then once you perform the updates, you ship back the product to the customer. The other way would be let the application engineer from your company visit the customer site and perform the firmware update manually. So this is the problem which we are trying to solve over here. So in this approach, we can remotely update the firmware. And the way we are doing it is using a cloud, okay? And for our project, we are using this board from STM, and this board has a Wi-Fi module. So basically, this board can talk to a Amazon S3 bucket and using your like Wi-Fi router, okay? So let me quickly jump to demonstration. So I have this board connected to my laptop, and these are the logs from the board. Okay. So if you see carefully, so currently it's application version 26. Okay, and it in the background it kinds of connected to my Amazon S3 server, and it finds that the firmware on the server is version 26. So it sees that my current version is also 26, and the version or the firmware available on the server is also 26, so it won't update itself, and this is happening periodically. Okay, now let me quickly update the firmware and show you a live demo of the firmware update. Okay, so let let's say I make some changes in my firmware, okay, and let me build it for you in the real time. And now this piece of changes I'm referring to as version number 27. Okay, meanwhile let me also update the version file. Okay, so let it build. It will it will take some time. Okay, so now I have this whole image built into binary, and I'm referring to this new updates as version 27. I have also updated the version text file. Now let me quickly upload it to the cloud. So I'm in my S3 bucket. So first I'm uploading the new binary file. If you see the timestamp, it's no, not this one. Yeah, if you see the timestamp, this is the the one which I built just now. Okay, let me upload this guy. Okay, so as you can see, yeah, this is reflected, and as you can see, the size of the file is like 334 KB. Let me upload the firmware file, the version file as well. So my version file will be here, right? So if you see the timestamp, yeah, and yeah, let me upload it. As soon as I upload it, my board should able to detect the changes. Okay, and yeah, it did. So as you can see, it it saw that the version on the cloud is now 27, and the version which is currently running is 26. So it knows that there is a new version update available, and now the next thing it does is it's trying to download this whole binary file. The way we are doing it, we are kind of downloading this whole file into chunks of 1K piece, 1K. Okay, the we are not downloading whole 3 130 kbs. We are kind of downloading 1 kb at a time, and this file will be downloaded to a different sector in the flash. We are writing like we are downloading it into a bank too. Okay, now bear with me. Let's give it some time to download the whole file. It won't take that long. Okay, so it's already downloaded that around 250 kbs. Just 10 more kbs. Okay, almost done. Okay, so now once it's done, yeah, so see, so here it has completed the like it has successfully downloaded the whole 340 kbs, and it perform like it kind of updated the metadata. Now bear in mind that this metadata will be used by my bootloader to decide which file to execute. Okay, and it perform a soft reset. Okay, and now here I have transferred the control to a bootloader, and here at this point of time I'm in a bootloader. Now once I press this button, I will I will execute a new image which I just downloaded, and let's see that. So you see, and now I'm executing a new image which is version 27, and which I just downloaded. Okay, and this is our project, guys.